Now from this lecture, we're going to start testing Angular components. In each lecture, you're going to see a pattern that you see in a lot of real-world applications. So let's start with the first pattern. In the folder called Setup and Teardown, open this vote component. So this is a simplified version of the vote component that you have seen in my beginner's Angular course. You have a property total votes and methods that modify the value of this property. The pattern we have here is state change. So in a lot of components, we have methods that modify the state of the component. Now in a real world scenario, chances are after modifying the state here, we may use a service to make an API call to save the changes on the server. That's a different pattern, and we're going to get that later in this section. So for now, let's just focus on the state change pattern. Now back here, we have a spec file. Here we have some boilerplate code, so you don't have to write everything from scratch. Note that the name of our suite is vote component. That's the system under test. Now let's write a couple of specs. So this vote component should increment total votes when upvoted. So here I'm going to create an instance of the vote component. Call the upvote method, and then expect that component.total votes to be 1. This is how we test this method. Now these 3 lines you see here represent a structure that you see in a lot of unit tests. We call this structure AAA, which stands for arrange, act, and assert. So the first line here is the arrange part, where we initialize the system under test. In this case, we're creating an instance of the vote component. The second part is the act, which often involves calling a method or a function. And the third part is the assertion. So as a best practice, to make your tests clean and readable, always put a vertical line between these lines. Like this. All right, now let's write the second test. So I'm going to simply select this, duplicate. We don't need this one here. All right, now let's change the name of the test. So should decrement total votes when downvoted. I'm going to change the call to downvote method, and then total votes should be -1. Now look at these 2 tests. These 2 tests have something in common, the initialization of our vote component. Now this initialization is only 1 line of code, and it's not a big deal. But sometimes when working with more complex objects, the initialization may involve a few lines of code. We can refactor these tests and move this initialization to a single place so we're not duplicating it in each test. So I'm going to cut this line here and move it inside the body of our suite. Delete and delete. Now each test is only 2 lines of code. However, there is a problem with this test. If we run this test, the second one is going to fail. Because in the first one, we're upvoting, so the value of total votes is going to be 1. And this means in the second test, the value of total votes is going to be 0, not -1. So the problem we have here is that our tests have side effects. The execution of one test can impact the execution of other tests. And with this, our test will break quite often, which is really painful. We don't want fragile tests, remember? So how can we solve this problem? Well, when writing automated tests, remember, each test should run in an isolated world, as if it's the only test that exists in the world, nothing else. So we want to start with a clean state. How can we do that? Now previously, we didn't have this problem because we created this component inside each test. But now that we move this line inside the body of our suite, we have this problem. The solution is to use the BEFOREACH function. So in Jasmine, we have another function called BEFOREACH. As the argument, we pass a function here. And our test runner is going to call this function before each test. And this is a perfect opportunity for us to initialize our objects. So I'm going to change this. Set the type of component to vote component. So we'll have IntelliSense throughout this module, and then do the actual initialization here. Now in Jasmine, we have three other functions that are similar to before each. We also have after each, and it has the same signature. So it takes a function that will be called after each test. And this is a place where you do cleanup. Now in this case, we don't need to do any cleanup, but in your test, if you need to do cleanup after your test, this is where you add your cleanup code. We have two other similar functions, before all, which is executed once before all tests, and after all, which is executed once after all tests. So in automated testing terms, we refer to what we write in the before each function as the setup, and what we write in the after each function as the teardown. These are the terms that you hear in a lot of unit testing frameworks, irrespective of the language. Next, we're going to take a look at an example of a form.